Good morning. So, hey again, hoping that the weather is treating you all well. As you are just joining us, you see the materials that you're going to need for our Mbadika, mLab / Autodesk Tinkercad Tinker Together webinar series. So, if you're just joining us, I see some new faces. Welcome, welcome, welcome. I'm your webinar host, Nisha McCrae. For those of you who need a couple more minutes, as always, we start 10 minutes after the top of the hour for you to go ahead and grab whatever materials you need in order to follow along with us as we tinker together. So go ahead and grab those materials. Once you have those materials, don't forget to raise your hand so I know you have those materials in order for us to get started. You'll notice there's one additional item versus our typical item list that we need in order to tinker together, and that's Luminol Foil. So go ahead and grab that if you have some. If you don't, do not worry, do not panic. But go ahead and grab those materials so we can get started. And the next, how many more minutes we have left? 11:03. We're doing something similar to what we did yesterday. So yesterday, we actually did our garden bed project. Today, we're gonna play around with how we can add some accessories to our garden bed project. And in particular, how can we add a lighting system to our garden bed project? So we're gonna do a little bit of circuits today, and then we're gonna actually craft by hand something to make sure that our actual garden bed gets sufficient sunlight. Because a couple of you asked me a couple questions in regards to, okay, so our garden bed that we started building this week, I want to make sure it gets maximum sun exposure, but I'm not quite sure if in my room or in the kitchen, etc., is going to get the amount of sun exposure it needs. Depending on what you're planning, you want to give it maximum sun exposure. So we're going to do a lighting system in Tinkercad Circuits. Then we're going to actually craft a bootleg lighting system, I like to call it, to make sure we can maximize whatever sunlight our actual garden does get in order to make sure it gets all of the sunlight and all of that wonderful UV light. And then last but not least, we're going to just review over some basic gardening tips, and that'll be it for this morning session. So yesterday we did a cardboard prototype of our garden bed that we initially designed in Tinkercad. So we're just going to be finishing off that project with a couple, here's some ways to take the project to the next step. The reason why we're doing that is because of the distance learning contest with Instructables and Tinkercad. So we're also going to go over the contest as well to end off today. If you have any questions in regards to materials you don't have on hand or other things you may need, feel free to send me a Q&A, and I could do my best alongside my colleagues to answer your questions as always. But we're not going to start until another 5 minutes. So you have plenty of time to make sure you have your materials. Make sure you're logged into tinkercad.com into your dashboard. We're not creating a 3D design to get started. We're going to actually do a circuit. So don't go in and it's the morning. Don't automatically start with the circuit. Don't automatically start with the 3D design. We're going to start with some circuits because we need to get some wiring out of the way first, if that makes any sense. And while I'm saying we need aluminum foil, I just realized I don't have aluminum foil after I just told you to go get some. This is what happens when you're building, or if you're cooking or you're making of any kind, that you're like, oh yeah, this is what my actual ingredient list is. And then you look over and you're like, oh yeah, I forgot that actual item. So I actually have to run, while I'm telling you to go run, I actually have to go run and go grab some aluminum foil. But in the meantime, feel free to grab the materials. If you have any questions about what you can and what exists in your house that you can use as a replacement for the materials, go ahead and send me a Q&A. So that way I know what I can actually help you out with, because we don't want you to just feel like you can't participate. This is tinkering together. So I just want to make sure we're all tinkering together and able to pull off some projects today. Also, if you did post your actual project progress, whether it was your Tinkercad model or your prototype from yesterday, and you use the hashtag, if I haven't liked or retweeted your photo on Twitter, Instagram, or Facebook, please let me know in the Q&A so that way I can keep track if we're missing some posts or they're falling through the cracks. Because I just want to make sure that everyone gets their shine and I actually see what you guys are making on the other side of the screen. Because even though we're not in the classroom or in an environment that I can actually see it, I still want to actually be a little bit nosy and see what you've been working on. Because after all, what's the point of tinkering if you don't get to share with folks and be able to learn from your actual tinkering? So go ahead and do that. Raise your hand when you have all your materials so I know that you're ready to get started. I see a couple folks are ready to get started. If you're not ready, no worries. You still have 3 minutes to go get ready. I'll go ahead and get the aluminum foil once we get to that part, just so I can make sure I don't waste any more of you all's time, because I forgot my aluminum foil. Also, it's weird because I've been using aluminum foil like all week. I don't know why I forgot that, but it is what it is. Let's see. I don't know what I'm actually humming there, so I'm just gonna let that one go. Okay. You have about 2 more minutes, folks. 2 more minutes. If you're keeping track of your time, you have 2 more minutes before we get started to grab those materials so we can tinker together. You have 2 more minutes. It's like the final countdown. Okay, that is definitely a copyrighted song. I just don't remember the name of the song. But I know that's definitely a copyrighted song. But I hope you guys are having a fabulous, trabulous Thursday. If you haven't, I hope you have one soon. Here, I'm always going to be talking about the weather because it's the thing that affects me the most. I'm going to say the weather's been it was sunny for like 45 minutes, and then it was dark and gloomy, and then it was sunny for 45 minutes, and then it was dark and gloomy. And it's been this teasing of whether or not we're going to have a nice day. So I'm keeping my fingers crossed that I'll be able to go back outside. Like this is the thing that I look forward to every day. Is today the day I get to go outside? Yesterday I was finally able to go outside because the clouds didn't look so ominous and so scary, but you never know. You never know. And maybe one day you're like, oh, I'm gonna be able to go outside, and then 30 minutes later it's raining cats and dogs, or cats and, someone said not cats and dogs, I should say cats and kittens. So it's raining cats and kittens. And you're like, oh no. But yes, so don't forget to raise your hand because that lets me know when you have all the materials you need in order to follow along with us. So raise your hand, raise your hand. So at least I know. And that's also because, you know, I'm that person. Okay. Oh, someone answered the question. So the song I was singing is The Final Countdowns by a group named Europe. You know, I've been on this earth almost 3 decades. I never found out who was the group who actually sings that song. I just know it from commercials when somebody's like making a decision. They're like, it's the final countdown. And I'm just like, okay, maybe it was like a jingle. I don't know, but I feel like it's an epic chorus to some kind of rock ballad or song that I just missed my era on that. Okay, so I want to see hands raised in order to know that we have all the materials we need in order to build today. And you know we're going to do some circuits because I have my space age turtleneck in order to feel the flow of making these circuits. Okay, I see a couple more hands raised. I don't like to start until I at least get 75% of hands raised because that lets me know that we're actually tinkering together and that we're going to actually be building together. So I'm going to wait. I'll give you guys 1 or 2 more minutes. I know some of the materials is going to take a second. I mean, like I said before, even I don't have the aluminum foil. I'm going to have to do some movie magic and dash in order to get the aluminum foil. No start is complete without my Hello Kitty water thermos. For those who've been on our actual webinar for the past 9 days, can you believe it's been 9 days? Time has just been going, whew. Like I barely even remember what we did last week. All I know is we've done a lot of projects, but hopefully this project we can end off with a bang so we can actually have a very, very special Friday session, which is keeping a secret. I see a couple people have just joined us. We're about to get started. We start usually 10 minutes after the hour, but these are the materials that you're going to need in order to follow along with us or tinker together. So the materials you're going to need, just because a lot of other people just joined in, are paper, some scrap plastic wrap. When I say scrap plastic wrap, I mean that plastic film that's over packages and stuff, a writing utensil such as a pen or a marker, cardboard or wood. I'm going to show you what I did with my wood in order to make my final prototype of my garden bed. And don't laugh. You're going to see why I'm saying don't laugh. We had an incident last night in regards to my project. So yeah, that happened, but it's functional. It's functional. On top of that, make sure you have your ruler. For those who have been long-time participants, you know your ruler is your friend. As you can see, my ruler has been through some things. So on top of that, don't forget to have your scissors. I'm using my scissors in X-Acto because I want to make sure that my prototype looks as close to what I would do in the actual lab as possible, just to let you know that the actual skills you all are learning in this Tinker Together session is pretty similar to what you would actually have to do when you go into anything in STEM. And for those who are joining us internationally, when I use the acronym STEM, that stands for Science, Technology, Engineering, and Mathematics. So anything in those fields, you're gonna have to know these skills, even in the math category. I know some people think, it's math, why would I need to know rapid prototyping? Trust me. When you're doing actual higher level math, sometimes you need to visualize what you're actually trying to solve in equations. And I have a lot of friends who are mathematic majors or have doctorates or have PhDs in mathematics who have had to create some visual models using some cardboard, hot glue sticks, and some tape. So don't think this is all just for engineers. This applies to every facet of your life, regardless of what career path or what you would actually like to do, even as a hobby. Last, glue or wood glue. Wood glue, of course, if you're using wood pieces, and then computer with Tinkercad account. Now, I will say for the model that I'm going to show you that I made last night, inspired by our Tinkercad model that we did, and then slowly moving on, I would prefer, and I'm just going to say this as kind of a perfectionist, I would have preferred making it with nails and a hammer, but I realized that what's the point? I know I can do it with nails and a hammer, so why wouldn't I just do it and challenge myself with doing it with wood glue and trying to find weights from various items in my home? That proved to be a very significant challenge, I'm not gonna lie. So, where it is what it is right now. So let me see your hands raised when you actually have your items, because I really want to get started. And you probably want me to stop talking. So raise your hands to make sure. Okay, some people forgot to raise their hands and are now raising their hands. Perfect. So let's get started. So over the past couple of days, let me go ahead. Perfect. Hello. So over the past couple of days, starting this Monday, we've been working on a garden bed project. And that garden bed project has been basically taking our Tinkercad model of a garden bed that we based off of this thing right here. This thing with all the writing and color on it is a shim. A shim is just a cheap piece of construction material you can get at a home improvement store. We basically took this shim and we designed a whole Tinkercad model around it. So basically, if you remember from earlier this week, if you're just joining us, hi, we took this piece of wood and we measured it. It was 12 inches, boom. We took the width, which was 1.5 inches, and we used a special tool in order to figure out the thickness. Now, using a measuring tape or a ruler for something that's less than ½ inch is kind of difficult. So we used our trusty pair of calipers and we measured the actual thickness of the material to be about 0.25 inches. Once we figured that out, we actually took this little plank and created a design to figure out, how could we build an actual garden based on this as our building material in Tinkercad? So what we did in the Tinkercad environment, let me go ahead and shift windows. No. Okay, so Tinkercad has decided to delete my CAD model. Let me regroup myself and go back into Tinkercad. Give me a moment. You know what? Why do I need to regroup myself? This is fine. This is fine. This is totally fine. So Tinkercad seems to want to play games today, and my model has disappeared, but that's okay. I can actually just ask you all for help, right? Like for everyone who was here the past couple days this week, can I ask you all for help? If you're just joining us and this is your first day, don't worry, this is us doing the review. I'm pretty sure the couple of familiar faces I see in the actual participants list can actually help me put this together. So first things first, what basic shape did I use from the right-hand side in order to replicate my shim? So what basic shape from the right-hand side did I bring over to my work plane in order to get started? Go ahead and let me know in the Q&A spot. I see a couple of people. You gotta be specific. Someone said a cube, and I think a cube, a box. Okay, let me look over here and let me figure out what we're talking about. Okay, so I see a box. So I'm gonna bring that over. And I made this the dimensions of my actual shim, right? So I made it 1.5 inches. Oh, okay, so this is in millimeters. So what part of Tinkercad do I actually have to go to in order to change it from millimeters and to inches, which is what I want to do since my measurements are in inches? Go ahead and let me know in the Q&A part. This is your warm-up this morning. Help me, help me. Ooh, one person being fancy saying a cube, box, or rectangular prism. Yes, all of those apply, but I need you to help me. Where do I go in Tinkercad in order to change from millimeters into inches? Okay, someone got the answer. Someone said, go to the bottom right corner. So let me go to the bottom right corner. I see my snap grid is telling me millimeters. I'm guessing this is the button I should click. And there we have it. I can go from millimeters to inches, and I could change my width to about 36 inches, tab, and then change my length to 36 inches as well, or 3 foot by 3 foot. Okay, let me go ahead and update the grid. Okay, my grid looks pretty big. And if I look down here, I know I'm in inches because I see snap grids in inches. Okay, so now I have my box, cube, or rectangular prism in inches. I'm gonna click my lower corner. I'm gonna change it to 1.5 inches by 12 inches. So we're gonna make a real long plank. And my thickness is 0.25 inches. Now, as I remember, I changed the color to something more wood-like, right? So now that I actually have my first shim, what should I do next? Did I use some kind of tool in order to do my next step, which I'm guessing is to make a plank with 3 of these as like a side? How did I actually do that? Go ahead and let me know in the Q&A. What tool did I use in order to create 3 of the exact same planks? What tool did I use in Tinkercad in order to make 3 of the exact same planks? Okay, we got a little bit of we have a little bit of a contest here. Okay, we have some people saying the duplicate tool and some people saying the copy tool. So let me see what it looks like with the duplicate tool. Let me go ahead and put a spotlight here. I'm gonna go over, and this is my duplicate tool, right? It's Control-D on your keyboard. I'm pressing Control-D. Okay, let me move my duplicate in order to show that copy. And if I press the duplicate again, I have my trio, right? But I'm gonna be a little selfish. I'm gonna go ahead and just group this, right? Because I already made 3. What tool do I use in order to group each of these individual planks? What is that actual tool called? Let me know in the Q&A. Okay, a couple of people are like, I got this. One person even said, I'm on a roll. Okay, come on, come on, come on. So let's go ahead and select this plank, and this plank. And we're gonna go over to the group tool, which is Control-G on your keyboard. I'm gonna click that, and it just made the plank, right? Now, this is a problem. What do I need to do to make sure I can still see the individual lines of the plank or the individual colors, the multiple colors on my plank? You guys are already on the drill. You already know the drill. One person asked, what's the height? The height of my plank is 0.25 inches. That's the thickness of the wooden plank that we're using as the base for our garden bed. And someone was like, okay, if you want to keep the individual colors, you have to go to multicolor. So I'm going to go to my shape toolbar, I'm going to click, go down to multicolor, and boom, I'm going to show the different colors here. But I'm still having the problem. It's still one color. What else do I need to do? Like, I'm going to ungroup. There was something I did to make it almost like a gradient or a wide variety of colors to make it look more like it was various types of wood. What did I do? The multicolor tool, yes, but in order for it to have multiple colors, in order to use the multicolor tool, it has to have what? This is for the big thinkers. In order for us to use the multicolor tool, we have to have multiple of what? Yes, you have to ungroup it, and we have to make multiple of what? To use the multicolor tool, we have to have multiple of what? Okay, yes, someone figured out that I was giving a huge hint. We have to do multiple colors. So what we actually have to do, I'm gonna try to click off. Sometimes Tinkercad does this weird thing when I'm doing the Zoom webinar, I've noticed it won't let me click off. So forgive the random box over there, it has nothing to do. We have to do multiple colors in order for multiple colors to show up when we use the multicolor tool. So right here, I'm gonna change the colors here. In order to do multiple colors, I'm gonna go back, pressing my shift key and select all the planks. And then I'm gonna do the group tool or use the group tool. It went to one color, but I can go back to my color icon, click multicolor, and now we have the individual planks showing up perfectly for our model. So next up, I need to make this go from horizontally to vertically. So what am I looking for on the work plane to make this go from horizontally to vertically? Let me know in the Q&A part. How am I going to make my planks go from horizontally to vertically? Okay, somebody said arrows. Someone said the protractor tool. That's another way to say it, yes. Someone said the double arrows. Yes, all of those things mean the same thing. Okay, you guys are alert today. I'm surprised that we're so close to Friday. So you see here, let me go ahead and put my spotlight. You see here we have the double arrow tool. We're gonna click it and rotate it 90 degrees. In order to make our first plank, I'm gonna tilt it on its side, go up, making sure the space here is 0. This here indicates how far the actual object is from the work plane. So we're making sure it's 0. And now we're looking here and we have our first plank, right? Now, a garden has 4 sides. So what tool did we actually use in order to make sure that our first side, when it duplicated, it rotated 90 degrees? What tool did we use in order to make sure that when we multiplied this actual side, it rotated 90 degrees to make side 2, 3, and 4? Go ahead and drop your answer in the Q&A. What did it do? How did we do that? Okay, somebody said, I believe it's the duplicate tool. You are correct. So what I did is go to the duplicate tool and actually rotated using our double arrow or protractor 90 degrees. Once I rotated it 90 degrees, I used my actual keys, the arrow keys on my keyboard, in order to move it up. To make sure I moved it up correctly, I went to my left-hand side, used the top angle, in order to make sure it was precise. And to zoom in, to make sure it was precise. Now, it looks like it's overlapping, and when I do one keystroke above, it's not overlapping. What tool could I use to make sure my gap between my up and down key isn't so big that it's between a huge gap or the 2 pieces overlapping? What on my work plane could I use to make sure that there's a gap in between. What could I use? What could I use? Is something on this work plane I can use in order to make sure it's not going from a huge gap to overlapping when it comes to my actual grid. Someone said using the center tool. Another person said use snap grid. Another person said use the align tool. I'm going to give you guys the answer. So the answer is using that snap grid. So I'm going to go down here, and instead of making it 1/8 of an inch, I'm going to actually make my gaps larger. So each of these little squares here represents 1/8 of an inch. That's what your snap grid is telling you here. I want my hops to be smaller, so I'm going to do 1/16 of an inch. And as you can see here, when I make the movement, it's no longer overlapping gap. It's moving perfectly. So now I feel comfortable that this is aligned, this is good. And now I'm going to click my duplicate and repeat tool, and ta-da! You see that it actually created the same method, and without clicking off, I can click it again and make my 4 sides. Now, the final task. Ooh, that was zoomed in too big. Okay. So now we need to make our base, right? So in order to make our base, I think we took our side, right? We took one of our sides and we copied and we pasted, because now I'm remembering a little bit more. Now, we no longer want our CAD model to be sitting vertically. We want it to be sitting horizontally. So what do we need to do? I think you guys said it, but I just want to hear you all say it again. What tool do we need to turn it from vertically to horizontal? Because before we did horizontal, then vertically. Is it the same tool we did before? Yes. Oh, okay. Everyone's like, okay, we got this. We got this. There should be a prize at the end of this, as one person said, but you know what? That's not up to me. It's not up to me. So I'm going to change my camera angle. So let me go ahead and put the spotlight back on it. Give us 1 second. Sorry, I think we just lost for some reason my ability to share screen. So give me 1 moment. I apologize. I was hopping back and forth too much. So let's go back into our Tinkercad model. And you can see here we have the double arrows. Let me go ahead and put a spotlight on my mouse there. You see we have those double arrows. Let me go ahead and click my upper corner, use my double arrows, and flip that bad boy 90 degrees, because that's how we do it. So flip it 90 degrees, go to my left corner, change my camera angle, and you can see that we have our base here. If I change my camera angle to the top view, I mean, it looks like she's okay there, but we got a lot more space to fill up. So I think we're gonna have to use that duplicate. Ooh, wait. Oh, that can't go. I remember doing this black triangle and moving this back down so it sits right on the work plane, or 0 inches off the work plane. Okay. Whew, that was getting a little dicey. So now we have to do, I think, the duplicate and repeat step, right? Right, I remember this. Hold on. So I'm going to go over to my left-hand side, click the duplicate and repeat, and then I'm going to use my keys in order to do this. And then because the duplicate and repeat is going to repeat it, oh no. Okay, we have a problem. What do I need to do to get rid of this extra plank? What do I need to do so it's not, how do I need to do that? What do I need to do to that last plank? It seemed to work well, but it seems like, Okay, someone said I need to ungroup. Okay, let me try that. Ungroup, so I ungrouped it. I guess when I ungroup, I could just delete. Let me look at it from the top. I could just delete that little plank, making all that trouble. Should I actually group these last 2 planks? Raise your hand if you haven't already done so. Raise your hand if I should group this plank and this plank to make it all happy-go-lucky, to make it all right, to make it go back to being nice. Okay, I see a lot of you are saying, group these last two that I just ungrouped and make it a group. I'm gonna select, sorry, that was my horrible attempt at a velociraptor squeal. I gotta multicolor it. See, I'm learning, even though I've done this multiple times. Sometimes you need a refresher. Okay, so now I'm gonna select all the ones on the bottom. I'm gonna go to my left-hand side, check my camera angle, go to the bottom and shift it over. Boom, 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 boom. Okay, looks good. I'm gonna group it. So I remember this part. And, oh wait, there's a gap. Ah! Ah! My perfect plan was coming together so beautifully before all this. Okay. Ah! Okay, hold on, I got you, I got you, I got you. It's not coming together. You guys have led me astray. I believed in you. Okay, let's go ahead and group. And we have pretty much the base of our box. If I remember correctly, all we did is we added some soil and we added some plants, right? So that essentially was our actual garden bed. I'm gonna go ahead and delete this bad boy here. I'm gonna click, drag over, and group everything to make it hunky-dory. So I want you to lower your hands now, because I have a question to ask you all. This was pretty much our garden box, right? Raise your hand, let me know. This was pretty much the garden box we made yesterday, if I remember correctly. Let me see them hands, see them hands. Okay, so everyone's like, that's the garden box we made. So pretty much that was the box. We created a cardboard prototype that looks like this, and we used this with some cardboard. We had some plastic lining inside, just so we could know if we were spacing it out correctly. So we found out we can do 4 succulents and put it at the bottom of our actual cardboard piece. And we also started our little seedlings. I can't tilt them up as much, but we started our little seedlings. And then we added our succulents and we added our kidney beans to our actual project yesterday, right? So what we're gonna do today is gonna require us getting on Tinkercad Circuits. So everyone's with me? Raise your hand. It seems like everyone is with me right now. Good, good. So what we're gonna actually do right now is we're gonna go over to our Tinkercad Circuits in order to get started making it a little addition to our garden. So who knows what you actually need in order to have a plant grow, a healthy plant grow? There's 3 things that plants really need in order to grow. Go ahead and send me your thoughts in the Q&A part. What 3 things do plants need in order to grow healthy, happy, and with a very good balanced life? I think that's how the saying goes. Happy, healthy, whatever the Cheerios commercial is. Okay, I see a couple of guesses. So one person said soil or some kind of plant food. Another person guessed sunlight and water. Some people are saying water, soil, sun. I see you. Okay. So any of those items you can actually use in order to make sure that your plant grows healthy. One of the things we did yesterday is that we took coffee grounds and we actually used that in order to plant our kidney beans and our succulent leaves based on our real life cardboard prototype of our Tinkercad model. And using our egg carton to hold our little seedlings, we actually planted them with the coffee grounds, add a little water, but we really didn't think about sunlight, right? So when we're thinking about sunlight, there's a particular type of light that comes from the sun that plants actually need. What is the name of that type of light? It's 2 letters. It's the name of that type of light. Some of our indoor garden enthusiasts have come to the rescue. So the type of light that comes from the sun that plants actually need in order to get started with the process of photosynthesis, the process that plants go through in order to make food for themselves, is UV light, which stands for ultraviolet light. I see a couple people like, yeah, I got it. So we need to make sure that our plants get sufficient ultraviolet light. This is why it's so important to make sure our garden bed and the seedlings inside have a sufficient light source, because that's how they process the nutrients from the coffee grounds and soil and the water, and they turn it into food to sustain themselves. So we need to figure out ways to make sure our garden bed project gets sufficient light, right? So today, we're going to utilize our old friend Tinkercad Circuits in order to come up with a plan to actually light our garden bed. Now, you may be thinking, what does Tinkercad Circuits have anything to do with ultraviolet light? So, for those who were with us last week, you may remember our Tinkercad Circuits project. The Tinkercad Circuits project that we did last week was a LED, or a simple LED circuit. LED standing for light emitting diode. I like to call it the light bulb. So when we made our simple LED circuits in Tinkercad Circuits, we usually just had an LED or an actual thing we're turning on and off. We had a power source such as a coin cell battery. And on top of that, we used a couple of wires in order to allow for electricity to flow, and we used a push button in order to control whether or not that light went through or whether it turned on and off. Today, what we're going to do in order to create an ultraviolet light system for our actual garden bed is we're going to actually take that same simple LED circuit, so this is your LED, in order to create that lighting system. Now, you may think an LED is not the same thing as ultraviolet light. That's where you're wrong. So there are actual ultraviolet light LEDs that exist in the world. This is one of them. You can actually create a simple lighting system that provides the same light that your plants will get from the sun using ultraviolet light LEDs. Now, this is something you may not have in your home, but it's a great exercise on how you can use Tinkercad Circuits in order to create a very advanced electronic system or circuit system to control the actual garden and make sure that your plants get sufficient light. After we do our simple Tinkercad Circuits exercise, I'm going to show you a more homegrown way to actually make sure you can get sufficient sunlight or ultraviolet light to your plants. So raise your hand if you're ready to get started into Tinkercad Circuits, and let's build out our actual ultraviolet light. Okay, I see the hands being raised, Make sure you have your Tinkercad accounts ready, and let's head over to our dashboard. And let's go. I don't know why it's taking so long, but let's go. Awesome sauce. So you see here, my dashboard hasn't become any less cluttered or disorganized as it was before. I'm going to go over on my left-hand side. Ooh, thank you guys for letting me know. The spotlight thing is something I forget because it's not a default in Zoom, but thank you for letting me know you need to follow along with me. Going over to my left-hand side, I'm going to click Circuits, and here I can actually go to create a new circuit. I can see my previous one, but I'm not going to be bothered with that. I'm going to go to my Create New Circuit. So once I'm going in, I'm actually in my Create New Circuits template. What I'm going to ask you all to do as your final warm-up for today is to create a simple LED circuit. If it's your first time actually joining us, don't worry, I'm going to show you how to make one, and then we're going to explore some things in Tinkercad Circuits that we can use in order to create an ultraviolet lighting system for our garden bed. So first things first, we need to have an LED for our LED simple circuit. If you've already seen this, this is your warm-up. Go ahead without us. This is just for folks who haven't seen it. I don't want them going around like, I don't know what this is. This is so confusing. So here you have your simple LED. I'm going to change the color. I'm going to make it blue. I'm going to grab a coin cell battery, which will be our power source, and bring it over here. What I notice with my coin cell battery is that I have a red lead or a red piece coming out. As you can see when I zoom in, you have the red piece. You also have your black piece. Your red piece is known as positive and your black is known as negative. If you've ever taken a battery such as a AA battery or a AAA battery, you'll notice that each ends have a positive and a negative. That's just dictating how electricity flows through the power source. However, we have to keep this in mind when we're wiring to other electronic components. For example, if we look over at our LED, we'll notice that our LED has one bent leg and one straight leg. The bent leg is known as an anoid. The anoid is the positive leg of our LED, and the cathode is the negative leg of our LED. Now, you may be wondering, how do we know which lead or leg to plug into where? Well, one of my popular sayings is positive people hang out with positive people and negative people hang out with negative people. If positive people hang out with negative people, then the feeling is kind of neutral in terms of nobody feels more positive, no one feels more negative. Everyone kind of feels like, it is what it is. I use the same principle when I'm wiring. So for example, I'm going to click the positive lead of my coin cell battery, and I'm going to bring it over to the positive leg or the anoid of my LED. I'm going to change the color to red, and then I'm going to click the negative lead of my coin cell battery and connect it to the negative or the cathode leg of my LED. Change the color, make it black. Now, in Tinkercad Circuits, I can simulate whether it worked, and as you can see, the LED turns on. However, as we discussed last week, when we wave our wand or wave our little mouse around, it's telling us there's too much current or there's too much electricity flowing through our LED. So in real life, this would actually explode. But luckily, we're in a virtual environment. So we needed to put something in here in order to make sure that it didn't explode. For those of you who were here last week, what did we actually put into our LED circuit in order to make sure it didn't explode? Go ahead and submit your actual response in the Q&A part. What did we put in to resist the current? Okay, I get it. You guys are like, Miss Nisha, I already know this. I understand. It's a resistor. So the component we add is a resistor. In order to add that component, we want to make a circuit or a loop, right? So as you can see here, we start here, go through the wire, go through here, and end here. We want to keep that same pattern. So we're going to delete the wire, through the wire. I'm not really good with songs. Bring our resistor here. Now, I don't want my resistor being vertical, so I'm going to go over to my upper left-hand side and click the rotate button and click it several times in order I rotate it the way I want to. Now, that looks pretty decent. I'm kind of a stickler for things looking pretty. So now I'm going to connect the negative lead to one end of the resistor. One of the nice things about a resistor, it doesn't matter if you plug it in backwards or which orientation you have it, because it just needs the electricity to flow through. So we can have it wired any which way. And then we're going to wire this up to the cathode, just like we did before, or the negative leg of the LED. So we're going to make it black so I know that's the actual negative lead coming into the actual coin cell battery. And so now we have our actual simple LED circuit. Let's start the simulation, and we notice that this LED is not as bright. If we click the resistance, we can actually change how much resistance is going through and play around with the number if we want this to be a little bit brighter, as you can see I'm doing here. And when you change the actual numbers, you'll notice the color of your resistor should change as well. That's because these actual stripes on resistors lets you know the amount of resistance you can expect from that resistor. So hopefully everyone enjoyed that brief review of a simple LED circuit. I hope everyone's feeling really confident, remembering all the stuff that they learned, because we're about to get a little bit more dirty. And I say dirty in the sense that we're going to learn a little bit more. If you're just joining us, welcome. We're just getting started in Tinkercad Circuits, so feel free to enter your Tinkercad.com account and join us in Circuits, because we're about to get started on how can we make the ultimate ultraviolet system for our garden bed. So what I'm going to ask you to do is stop your simulations, take a deep breath, and we're going to clear our workstation. So we're going to zoom out, and we're going to find another area to work on, right? When you do that, what I want you to do is go to your right-hand side, click the down menu, and I want you to go to Arduino. Yes, we're pulling out the big guns today. So I want you to go to your right-hand toolbar and click Starters and click Arduino. And what we're going to do today is get started with a very simple Arduino circuit. For those who aren't familiar with Arduino, no worries. We're going to I'm not going to call it a crash course, but we're going to do a course. on actual Arduino wiring. So go ahead and do that. I'm going to pull out my board and a couple of other things. And when you are ready for us to start, go ahead and raise your hand so I know that you're with me and that we actually have the go ahead to get started. So when you actually see this actual toolbar's up, what I would like for you to do is quickly look at all of this stuff you see here, all of these options. We're not going to do all these options. What I want you to do is simply look for the blink Arduino circuit. That's all we need. We're going to get started with this Arduino circuit. Make sure you have enough room, because as you can see, she's big. Zoom out just a little bit if needed. And you'll notice some familiar pieces that we already had experience with in the past. So go ahead and do that. Once you have your Arduino on your actual Tinkercad Circuits layout, go ahead and raise your hand so I know you're with me. And don't be shy. If you have a question, go ahead and ask me in the Q&A part of the Zoom webinar, so I can be happy to actually, because I'll be happy to actually assist you. So once you have your Arduino blink starter circuit on your work plane, go ahead and raise your hand so I know that you're with me. And as I said before, my rule is I don't move until 75% of you all are at the stage that I need you to be at for me to move. And that's because this is called Tinker Together, not Nisha tinker and show how smart she is, while the rest of you are struggling trying to figure out what on earth I'm talking about. Because that's not fun. I know some people think that's fun. It's not fun to me. If you have a question, go ahead and ask in the Q&A. One person asked, where do I find it? One more time, you can find it on the right-hand toolbar. So if you click here, you will see you automatically start off with the basic components. I want you to go into the starter submenu and go to Arduino. When you're at Arduino, I want you to click the blink starter package. That's the one we're going to play around with today. And if you're scared of doing programming, don't worry. I'm going to hold your hand and I'm going to guide you through this. I think it's one of the most important skills you should learn. And I think it's so important to realize that even though a lot of times when we use Tinkercad software or doing computer-aided design models, we think it has to be for something physical and that it can only be for building things. And I want to show you today that there's a lot in common between creating electronic circuits and creating CAD models, and you can actually integrate the two together. So that's what we're going to do today. So go ahead and raise your hand once you have your Arduino board on the middle of your actual work plane. If you're having problems, go ahead and raise your hand so I can help you with that. But it looks like we need 1 or 2 more minutes for everyone to be on the same page. Okay, I'm seeing a bunch of hands being raised. Okay. I need a couple of more hands raised before we move on. Everyone's like, it's so stressful. I know. That's what I said. Everyone was like, why was she doing such a long intro? The reason I was doing a long intro was to make sure you felt comfortable, you were refreshed, you weren't coming from, I just woke up this morning, in order to make sure when we got into the dirty, you were ready. You were ready to get started. Okay, it looks like we have most people's hands raised. So what I'm going to do is jump into it. So what we have here is an Arduino Uno. An Arduino is a microcontroller, which means it's micro or small, and it controls things. So remember what I said about a simple LED circuit. A simple LED circuit is a circuit that uses a power source in order to turn something on and off. So a simple LED circuit is a circuit with a simple power source, like our coin cell battery, like that boy over here. Let me go ahead and minimize that. Like that bad boy right there. And an LED in order to have something happen. We added a resistor because we didn't want our LED to explode. And what we did last week is we added a control. The control we used was either a push button or we used a slide switch. Some of you, I remember, used a push button. If you want to know what a push button is, this bad boy here is a push button. Another type of control is a slide switch. So the way we actually use these two types of controls is we can actually just do delete an actual wire through the wire. I don't know why that song comes on when I'm actually doing wiring, so forgive me, that's not by choice. And Tinkercad is slowing down a bit. There we go. Let me go ahead and add the push button. For those who remember, we actually could wire the push button diagonally. So we do this one here. I'm going to change the color to red. And then we added a connection to the LED positive flag or anoid. I'm also making it red so it's easier for me to know. And when we actually press start simulation, we'll notice two things happening. When we add our control, we turn our LED on in our simple LED circuit, right? When we look at our Arduino board, the actual control for our Arduino board is the Arduino board. So we can look at this LED and we see that it's slowly blinking, right? It's slowly blinking because the Arduino board, the control, is telling it blink so many seconds. Oh, blink ever so many seconds. Again, you have your resistor, as we saw over here. We added a resistor to make sure this LED didn't explode. So we understand that just like we have the push button here, in order to control our LED in our simple LED circuit, we can actually do the same thing, but use an Arduino board in order to control when an LED turns on or when something else happens. So when we're actually looking at creating a simple LED circuit, all we need to do in our LED circuit is replace our LED with a UV LED in order to transform our circuit into a circuit that can provide UV light to our garden bed. But hey, you guys already know a simple LED circuit or a simple way to add a UV LED into your garden bed. Why should we waste more time on that? Let's crank it up a notch. Let's actually try to figure out if we can program something to actually provide UV light at certain times of day or ever so many seconds. That, ladies and gentlemen, dogs and kittens, is more of a challenge I think is appropriate for you all. So you see the virtual Arduino Uno microcontroller, right? This is what it looks like in real life. As you can see, it's about the size of a credit card, about the size of my hand. This is actually what the real one looks like. So the Tinkercad Circuits model pretty much holds its snuff when it comes to this one. Sometimes you'll see this actual board is connected to the breadboards I showed you last week. There's other types of Arduino boards as well. Because one thing is, if you have projects, this is kind of big, right? Like nobody wants to have this chunking around in order to control something. So there's alternatives, such as the Lily Pad, which is an Arduino board. It's a cutesy Arduino board. This one I love because you can actually use it for clothing projects. So let's say I want to control LEDs that are in a dress that I'm making for Comic-Con or some kind of special episode of mLab. Like one episode, we had a spacesuit that we made and we wanted to control when the LEDs turned on. I would sew this using the holes here into my actual article of clothing to control when my LEDs would turn on or when something would happen. So this is just a more advanced push button. If you want something even smaller than the Lily Pad, another type of microcontroller or Arduino is the Arduino Micro, or otherwise known as Nano. And as we can see, the Micro versus the regular size Arduino is kind of night and day. I can easily fit this into a hat behind my goggles and a backpack or clothing in order to control something, versus this bad boy, it's the size for a robot. I mean, it's pretty big. I like it because if it's your first time playing around with something, unless you're doing something high powered, it's really great because you can figure out the holes, etc. But all these actual pieces are available in Tinkercad Circuits, because one of the great fears when you're playing around with this is A, am I doing this right? B, am I going to destroy it? And C, am I really going to destroy it? So we're using Tinkercad Circuits in order to create a prototype of what this will look like. You don't have to have an Arduino board, etc., in order to bring this to reality. This was something I wanted us to do because I got a lot of requests from you all to do more with circuits, in particular, show you all Arduino. So that's what we're going to do today. So now that I've shown you all the Arduino boards, let's go back into our virtual board and see how it's brought to life. So here in Tinkercad Circuits, you'll notice that we still have this little LED blinking very slowly. One of the cool things we can do in Tinkercad Circuits is actually go over to our right-hand side. Let me go ahead and put the spotlight over here. If you click code, you can actually see what's going on with the Arduino. So Arduinos actually operate based on code. The reason it does this is just like when you're talking to someone who speaks another language, you need to use a translator. I don't speak machine, you don't speak machine in our everyday language. If you're listening to this actual webinar session, you most likely understand English. So when we are talking, we're speaking English. However, if I had my friend who only speaks Portuguese, I would have to learn Portuguese in order to communicate with her or rely on a translator such as Google Translate. And that's essentially what this actual section is. I am learning how to transform what I want my Arduino controller to control and using these things called blocks in order to communicate with my Arduino. Remember, I keep emphasizing that the Arduino is a control, just like a push button, just like a switch. So we can control what the Arduino actually does with our LED. So let's look here. It says this program blinks pin 13 of the Arduino, right? Pin 13, that's kind of a weird thing, right? What on earth is a pin 13? If we look over to our Arduino board, you'll notice there's multiple numbers, right? We see numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And what do we notice at pin 13? We notice a wire coming out of pin 13, a resistor going through an LED, and then coming back to ground. So, just a quick vocab clear up. When you're dealing with an Arduino board, you'll notice that it says ground and it'll say power, or it'll say 3.3 volts, 5 volts, ground. Let me show you what that actually means in our Tinkercad. This is why I was showing a side-by-side of our simple LED circuit versus our Arduino board. So if I click the actual code button again, it allows for the code section to disappear. If I look over here, you'll notice there's a number. The number you see here is 3 volts. That means the amount of voltage going from the positive and through the circuit and back is about 3 volts. When I look over to my Arduino board, you may notice right here, let me zoom in. You'll notice this says 3.3 volts and this says 5 volts. And then you see ground and ground, or GND. So remember, in our actual coin cell battery holder, we have positive and negative. On our Arduino, our positive is represented by how many volts is coming out of our Arduino board. So you can choose between 3.3 volts, which is about how much comes out of our coin cell battery, or 5 volts, which is what you typically will get if you're charging your cell phone, etc., from a wall socket. If we look down here where we see the GND, this stands for ground. Ground is another way of saying you're negative. So this is how you keep yourself grounded. So here, it will be the same equivalent of the negative lead coming out of our coin cell battery. So now when we look at our pins, this makes a lot more sense. This is why we have the 13 pin, or all these number pins, must be acting like the positive lead from our actual, hold on. I want to make sure I get both in screen, so give me one sec. There we go. So the 13 pin is actually acting like the positive. So power from our Arduino board must be flowing through these pins, and ground is acting as the negative, just like we have a negative lead in our simple LED circuit. Now you may be asking, how is power flowing through these actual pins? Hey, remember when I said that nerds like to keep it simple? Remember our breadboard, and we have all those holes in our breadboard? Well, it's the same thing. If we actually added a power source to our breadboard at a certain spot, of course, now that I want to show something, I can't find my things. Oh, there we go. It just disappeared. So let's say we're actually using our breadboard like we did last week, for example. And using our breadboard, I'm going to take a coin cell battery, pop this bad boy open, and I'm going to take a battery holder. This is my fancy battery holder. Slide it in. And where you see on my breadboard, I have the positive rails and the negative rail. I'm going to go ahead and stick this in. So it looks like this. So now I know there's power going through the positive rail and the negative rail. And I'm going to take my LED, I'm going to stick the positive leg of my LED, which is the long leg, and the short leg is the negative. I'm going to stick it in. Ah! And ta-da! Hopefully you can see that. My LED turned on. So what I'm actually seeing here is that I was able to use the rails in order to allow electricity to flow. The way that happens is that there's metal inside these rails that when you connect power here, it flows through. Same thing in an Arduino board. So when we go back to our Arduino board, we can see there's power flowing right here, from here through the resistor to the LED. So we now know that the code that says the Arduino is controlling power via pin 13, that makes sense. One person gave a really smart analysis and said, this looks a lot like the Scratch programming code. You're exactly right. This drop block feature is actually the same as Scratch. So you can actually go, okay, this is a comment telling me what this code actually does. When I go down here, this is another comment. This part of the code turns the LED on high, which is on, and the voltage level. So we see, let me zoom in a little bit. We see it says, turn the LED on high. Ooh, forgot my spotlight, folks. Thanks for letting me know. Turn the LED on high as the comment. If we look down here, which is the actual thing that we're controlling or telling our Arduino board to do, it says, set built-in LED to high. This is the command to allow the Arduino to know what to do. We see here how much time it's going to take before it actually turns off, which is what this is doing here. Turn the LED off by making the voltage low. I'm going to capitalize this, and you can see here I can actually edit it to add my own notes. So I can turn the LED on by having it high voltage, and I can turn my LED off by making it low voltage. And I wait 1 second before turning it off. So what I want you to do is click the time part and make it 10 seconds between when it turns on and when it turns off. So turn it on, leave it on for 10 seconds, and then turn it off and wait another 10 seconds before going back and turning it back on. Let's see what happens. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I was almost close, 10. So you see when we change the code here, that we actually could change this here. So the actual pin 13 is not only sending voltage or power to our LED, it's also controlling our LED. So it's controlling it based on the code we have here. So I want you to do, without me helping you, I want you to see what it looks like in 30 seconds. So I showed you how to do it in 10 seconds. I want you to do it in 30 seconds and raise your hand when you're done. Just so we're all in this together. Okay, I see a couple people raising their hands. I see a couple people raising their hands. Let's get to it. Change it so that it turns on for 30 seconds and then it turns off and then it waits 30 seconds in order to turn back on. Raise your hand when you're done. Okay, I see a couple hands raised. When you've done that, here's the bonus round. When you've done that, here's the bonus round. I want you to have the LED turn on for 30 seconds and then only wait 10 seconds to turn back on. So I'm going to say it again. I want you to have your LED stay on for 30 seconds. And then when it turns off, it only stays off for 10 seconds. I want you to try that. And then I'm going to show you how I do it in a sec. raise your hand when you think you got it. Raise your hand when you think you got it. I'm going to go over here. I'm going to show you the first one. 30. 30. And go ahead and see what that looks like. So you see when you press start simulation, the actual USB input for your Arduino actually plugs in. That's a cool little feature that I love to make it as close to realistic as possible because your power is coming from this USB cable. So we're gonna wait, it's gonna be about a big 30 seconds, so it's gonna take a bit of time. And let's see if it stays off for just as long. This is almost like watching glue dry yesterday when I was doing the project, so no sweat on this. Turned off, and it seems like it's staying off for more than 30 seconds. So what I'm going to do is translate this that it stays on for 30 seconds and it turns off only for 10 seconds. So let's try that one. If your code looks like this one, go ahead and give yourself a pat on the back. As you'll see, it stays on for a pretty decent amount of time. And now we're just waiting for it to click off. Yeah, turn off, turn off, turn off. Yeah, yeah, turn off, turn off, turn off. I know, I shouldn't have said 30 seconds. I should have said 15 so we didn't have to wait. Okay, and it did it. Okay, perfect. So we can go ahead and stop simulation. Now, when we're thinking about our UV lights, for example, right? It doesn't make sense for us to actually just think about this as we only need to turn one UV LED on, right? We're probably looking at something more like this. We want to turn multiple UV LED lights on in order to have exposure of our UV LED lights to our actual seedlings, right? So right here, I use my breadboard and a simple coin cell battery in order to light up 1, 2, 3, 4, 5, 6, 7. Whoa, I counted one extra. Sorry, my eyes aren't that great. 6 LEDs or 6 UV LEDs. So the light coming from these will be UV light, right? And this is going to be healthy and happy for my plants. Now, I want to actually have my Arduino board control 6 LEDs. How would I go about doing that? Let's go ahead and see how I would do that using my Arduino board. So going to my Arduino board, what I can actually do is stop the code for a second. So clicking the code button, going over to my little arrow I compressed, and then pulling some LEDs, right? So what I can do is pull a couple LEDs. 1, 2, 3. Let's just do 3. I'm gonna make them a different color. So I'm gonna make this one orange, because why not? And make this one blue, because why not? Now, there's multiple ways I can do this, but the first way I can actually do this is figure out a way to tie in all of the actual positive legs to control input 3, or the input pin, and all the negative legs to the negative leg here. I could also do it with the breadboard like I did in real life, but I'm not going to do that because I'm going to try to do it the way you all would do it. So first things first, I can actually stack these in free form. Free falling. And I know some people are going to be like, does she just sing all the songs she doesn't really know? Yeah, there's a pattern with me. I'm going to connect all the positive legs as you see here, making a whole row. Positive legs here. I'm going to go back and make them red. I know the default isn't red, but the red does help me out a lot in terms of knowing what's positive and what's negative. At a quick glance, I'm going to go back, clean up my work, make a leg positive, and feel free to follow along with me on this one. I saw one comment just asked, could we follow along with you? You're more than welcome to. This one I'm doing a little slower than I would normally do it, just so you can see what I'm doing. Making that red. And now I'm going to connect all the negative legs of the LED. Negative leg, negative leg, negative leg. Going to make those negative legs blackity black, black, black. Yep. And this last one, trying to be weird here, I'm going to make it black. And so now we have this going. So let's see if this works. I'm going to press start simulation and they all turn on. So I can actually create a row or a series or a parallel circuit. It's actually a parallel circuit, my bad. A parallel circuit of all my LEDs in order to have multiple LEDs controlled by this pin. But I don't like to stop at easy, right? How about we create our final UV light system in which these three here turn on and off every, let's say, 5 minutes. And then we create another series that turns on and off, let's say every, I don't know, give me a number, guys. We got one turning on and off every 15 and one turning on and off what number? Oh, someone asked a good question before you answer that one. Someone asked a good question. Do LEDs have UV light? No. You have to get LEDs that are specifically ultraviolet LEDs. So LEDs come in a wide variety of colors. Luckily, I have my whole case here. So let me change this quickly. So LEDs come in a wide variety of colors. So you have some blues, you have some greens and reds and yellows. These do not have ultraviolet light. The ones that I am using, the ones right here, are ultraviolet light LEDs. So the light that's actually being emitted or coming off these LEDs are specifically ultraviolet light. So this is actually the only LED that gives off ultraviolet light. I like using ultraviolet light LEDs because I do a lot of sanitation projects, especially during this time. You can use ultraviolet light in order to sanitize surfaces or cell phones, etc. If you feel like they've been exposed to any kind of germs or viruses, etc. In my apartment, I have 5 UV LED light systems I've set up in order to sanitize our cell phones and our keys when we come from outside, because wiping it down with a Clorox wipe, I know my boyfriend, he's not going to do that. So I want to make sure I'm protected. I use these UV LEDs and I make simple circuits like this and I turn it on. He just has to press a button to sanitize stuff. And also I like to use them in my garden projects in order to actually make sure that my garden beds get sufficient light, because I happen to live in a neighborhood that sun exposure, because we have a lot of trees, even though it's sunny, it's not enough sun to make sure my plants grow healthy. So no, long story short, not all LEDs have ultraviolet light in them. So here we're going to see if we're going to create another circuit. Let's leave this one as is. I'm going to show you how to make another one from scratch that is controlled by the 12 pin. And then we're going to get started doing a less complicated version to control our actual system. The reason why, someone asked another good question, reason why I'm showing you this is sometimes you don't want to just press a button like we have here. Sorry, I forgot to press start simulation. How could I do that? You don't want to just press a button in order to have something happen, right? You want to set a timer on it and forget it. And sometimes if you don't have those old Christmas lights timers, it's kind of difficult when you're gardening. Using an Arduino board as a microcontroller to control when your UV lights turn on is a perfect substitution, and I thought it would be a great way to put in some coding. So here we're going to create another actual circuit from scratch using one of these pins. I'm kind of biased. I'm going to go for the number 8. So we already know we need to bring in a resistor. So let's bring in that bad boy. We're going to wire the resistor to pin 8. And we're also going to bring in an LED. And we're going to wire one of the wires from our resistor to the anode or the positive leg of our LED. Now we have a problem. All of these are positive leads coming from our LED, right? So I can't simply go to the number 9 and go, oh yeah, if I plug in the negative leg of my LED to the number 9, that's going to provide me a circuit because number 9 is also positive. So I have to figure out a way around that. If you're looking at, well, the only thing on this side that isn't a voltage is this ground here, I need to figure out a way to wire myself into this ground or figure out a wiring to the grounds over here. So let's see what happens if we try to bootleg this wiring here. In real life, this wouldn't happen. We're just having fun. So let's click it and let's see what happens. Wait, my LED didn't turn on. What's that about? What's that about? Well, if our microcontroller needs to control something, just like our LED here didn't turn on unless we push the button here, we actually have to write a bit of code in order for this to actually get started. So let's go over to our code and let's actually drag some shapes here. So here, we are basically copying this exact code. So let's actually figure out where all these pieces are. So this here is just a comment box, and that color is gray. This looks gray. So let's just follow. And oh, wow, that was a lot simpler than I thought. Just gonna click here. It says describe your code here. Okay, our code is this program, blinks pin 8 of the Arduino. Perfect. So let's go ahead and get started actually writing the code. So this next color is gray as well, and we see its twin is right here, so let's drag it over. And basically it's saying, helpful single line command here. Okay, we're gonna copy like above, turn the LED on, which is high is the voltage level, which means when we turn it on, that's turning our actual LED circuit on. The next part here is in blue, so let's look for the equivalent color. That's the output. What we want the Arduino controller to put out, or the output. You also will see an input. We're not going to worry about input today. Input is the information we want our Arduino board to receive. That will be another day's lesson. But let's go to set built-in LED to high. So let's go ahead, drag that. And if you're familiar with Scratch, you know how to click it like a Lego piece and make it actually create a connection. We can see here, there's an orange piece here. Let's go over to control because it has an orange dot. And we can see the wait so many seconds. So we can bring that to up. And instead of doing 1 second, let's go ahead and make it, I don't know, let's just be crazy and make it 60 seconds. And let's go back to gray for what happens when it turns off. And you see how I'm just adding and snapping, adding and snapping. Turn the LED off. Voltage low is the voltage level because we're not having voltage go through it. We're going to go back to orange and grab a couple of seconds. And we're going to change it that it only turns off for 60 seconds. And then let's go ahead. Oh, wait, I missed a step. No! I'm just going to move it over here because I forgot to do a blue. See, you guys got to keep me straight. You have to keep me straight. I got so excited. And then here. Now I need to change this to low because it's turning off. But after it does the cycle, what the heck? Let's look at another one here. It says set a certain pin to something and set a certain pin to high. Let's actually drag that in. And let's say the pin is going to set to high. Is going to be pin 7. And I'm going to tell you the reason why I'm thinking this. So I'm going to go ahead, hide my code. Oh, someone just asked a question. Oh, what does the code say? It's really blurry. Give me 1 second. Let me see if I can zoom a little bit in there for you. They should really allow for me to like move this a little bit. So can you see a little bit better this area here? I have this program blinks pin 8. The next line is turn the LED on, set built-in LED to high, wait 60 seconds. This one is going to turn the LED off or voltage is low. I set the built-in LED to low. I waited 60 seconds and then I'm going to set pin 7 to high. So raise your hand once you've written this down. I'm sorry it was blurry earlier, but let me know when you've gone this far. And I'm going to show you why I added that actual section about set pin 7 to high. Or this part right here. So raise your hand once you have that and you've actually been able to copy the code. And then I'm going to show you what that looks like. And then we're going to move on to making our low-tech version of capturing some sunlight. This is where your cardboard and aluminum foil is going to come into play. And then we're going to end for today. My, it's already been an hour Geez, the time flies by. If you have any questions or any part of the code isn't clear, go ahead and ask me. As you see, I'm quite responsive. I have a bunch of people looking at your actual questions to make sure I don't miss any. So I got y'all. I'm going to give you guys a couple more seconds. Don't forget to raise your hand once you have the code so I know that you're good. Okay, I was just figuring out one more question. Let me see what hands are raised here. Raise your hand. If you have any questions, feel free to ask them. One person was like, it's just taking a minute for me to grab things. Just give me a second. No worries. Go ahead and grab those items. Like I said, this is us tinkering together, so we're not trying to rush you or push you through. We also post these videos up on our YouTube channel. So if there's at any moment you're like, too much is happening, don't worry, don't worry. We make sure you're able to revisit this. So don't panic, don't fret. I see a little bit of panicking happening in the Q&A part based on what I'm seeing. Don't panic, it's totally okay. Just make sure you can get to a comfortable spot and just raise your hand when you're at that comfortable spot. Because this is what we actually want to see, is seeing this original code, which is the code up here happening. And then we want to see this actually coming in and out. And the purpose of this code is actually for us to set a timer on when we actually have our LED circuit, or specifically our UV LED circuit, being exposed or exposing our actual seedlings to some light. So not only did we do some high-tech prototyping to create our garden bed, this is us adding some circuits, because hardware and electronics is such a beautiful marriage, to our actual garden bed. So go ahead, get your circuit together, press start simulation to test out if you have it, and raise your hand when you have your code good and ready. As you can see here, I've pressed start simulation on my end just to show you what it should look like. If you want it to be shorter, go ahead and change the time. For example, instead of waiting 60 seconds, wait 15 seconds. If you want to get a quicker feedback on whether or not your code is actually working. I like to set it with a little bit more time because I'm leading this actual group or this webinar. So sometimes I just want to make sure I have enough time to check your questions, double check if I can answer, help anyone individually, as well as making sure the actual simulation is going okay. So don't forget to raise your hand once you actually have the code, because once I get started setting pin 7 to high, I'm going to have to hide the code and make sure everyone is able to get their code straight before I actually hide it. So I see we have a couple more questions coming in. Some people are saying it's not working. Let me go ahead and show you what I'm doing. So if you look here, the most important parts of your code is that you've set the built-in LED to high, and you had to wait 30 seconds. Now, the problem you may be having is that your actual pin isn't on. So see here, This is such a horrible way to do it, but we're gonna do it. So here, you may actually have to do a little trick. So let me lower this down. You don't want to set this to high. We go ahead and remove this back over here. And let me change this to be every 10 seconds, just to make it go a little faster. So this should be actually turning on pin 8, but something seems to be wrong here, right? Oh, because I didn't start simulation. Okay, so this should actually be turning on, and we're noticing this isn't turning on. Let's stop simulation, and let's see if it was actually because of the negative leg or the ground leg of our actual circuit. Let's see if we needed to plug it in somewhere else. Hold on. Taking a second for my wires to catch up to my movements. So let's actually plug it into ground here and paint it black. And let's do start simulation. Do we notice a difference? If we look at our circuit, what do we think could possibly be the reason that our pin isn't on? Go ahead and let me know in the Q&A part. What do we think is a reason that our pin isn't turning on? Okay, somebody's already like, I'm trying to figure it out. No. We have set built-in LED to high, then set built-in LED to low. We have a resistor. The resistor seems to be 1 kilo ohm of resistance. This one's 220 ohms of resistance. I can change this one to 220 ohms. And we can start simulation again and see if that makes a difference. But I don't see a difference. So what could it be? One person suggested moving this here. Okay, I'm going to move this here. I'm going to move my block comment down, and I'm going to press start simulation again. So we see this happening. Let's see if this turns on now that all of this is within the same program. What could possibly be happening here? It seems like we did everything that the other one did. I want you to look at your actual blue blocks here and let me know what other thoughts you have, because I don't know. I'm sitting here waiting for this actual LED to turn on. Doesn't seem like it wants to turn on. What did we do wrong? What did we do? I see a couple people, we have that one, we have that one. Let's break it apart here. Whoop. Sorry, I did not give it enough space to actually get out the way. Okay, some people have sent me a question. They're like, how about setting it to high and then turning it off? So let's go here. It says set pin and drag it over. And the pin number we're working with is 8. Okay, let's try it this way. We're setting the pin already be on, and then we're going to turn it off after a couple seconds. Let's see. I'm not seeing any action here. So 2 things could actually be what's going on. Oh, wait. Somebody just said I jinxed myself again. That could be it too, but I've actually done this before. So 1 second. So I think it has something to do with this actual, here should only be telling me voltage, but this isn't the first time I've done something wrong. So forgive me for this torture I put you through. This is connected and this is connected. Set pin 8. Let me go ahead and change this to 5 seconds. Because I'm making sure my code is correct, because maybe I was rushing through this. So if you're having issues debugging, welcome to real life. Welcome to what actual engineers have to do all the time. And everyone's like the wonders of Zoom meetings. Yes, I'm going to say Zoom has jinxed me officially. I'm going to kind of look sideways at Zoom right now. Okay. I'm going to say I got 3 LEDs turned on my 13 pin. If you have any family members who can look at this and tell me what I did wrong, maybe I didn't have enough. Wait, now it's turning on. What? Why are you making me look bad? Why are you making me look bad on this Zoom meeting? Making it look like I don't know what I'm doing. Why? Okay, besides that point, you can now see that my code actually, yeah, it is working. So, yeah. Gotta let that go. I'm like, I've done this so many years. Don't try me. Don't play with me. But yes, so this is just playing around with our actual UV circuit. I think given the way Zoom is happening, Zoom took pity on me. Sure, it took pity on me. Whatever. I'm just gonna blame it on a technical issue. I'm just gonna say that. But it can't take pity if I didn't know what I was doing. So Whatevs. So now we're going to switch to actually creating a physical, more low-tech version of this actual UV light system, that instead of using UV LEDs, we're actually going to use the sunlight from outside in order to actually magnify that light to make sure we give our garden bed sufficient lighting. So what we're going to do is go ahead and make sure you have your aluminum foil, your ruler, your cardboard, all those materials we talked about earlier, in order for us to make our low-tech prototype to add a little bit more sunlight to our actual garden bed project. So go ahead and grab those materials. I'm gonna go ahead and grab my aluminum foil. So let's go ahead and take a minute or two before we get back into it. Also, Nisha's DJing again, so give me a second to switch positions. And it takes a moment. We're about to get started. Just give me one more second to get everything laid out. Hello, hello, hello. So as you guys can see here, here's the cardboard prototype from the other day. I need to give a little bit more moisture to my actual succulents because it seems like they need a little bit more love. As you can tell, that versus the other day, it's a little drier, my actual succulent plants. Making sure I'm adjusting some stuff here, just so you can all see. Wow. Wow. Perfect. Okay, so as you all can see here, my coffee grounds have dried a little bit, so I'm going to add a little bit more moisture today. My succulents right here, my other succulents here, and these two are the kidney beans that I use making an egg carton. So I'm going to put this safely out of the way. This was the original cardboard prototype of our garden, and as you can see, I have my 1, 2, 3, 4, my little layouts for where my succulents would be, that we measured out to see what they would look like when they're fully grown, to make sure our garden bed can actually grow along with it. In addition,
what I can actually do here is I can actually use my garden prototype and I can add my specific layout of my UV lights here in order to provide certain exposure of UV lights to my actual plants below. I can also do something that provides it at a tilt, as you can see, which allows for me to provide even more exposure to my succulent plant this way. So I want to do something like this with my UV lights, but I want to do it in a very low-tech way. So instead of having my one succulent here, I want to be able to provide UV light exposure from the sun in a more direct way. So raise your hand if you've ever had to make a solar cooker or make like a hot dog cooker before. So this is what I'm talking about when I say a hot dog cooker, not an actual electronic device you plug in to cook hot dogs. I've asked students this before, and I never knew that hot dog cookers were so prevalent, actual mechanical hot dog cookers, versus actually taking some aluminum foil and some cardboard and using UV light or the heat from the sun to actually cook a hot dog outside. Okay, so I'm seeing that right now. Okay, some people are asking me questions. So give me one sec. Yes. So a solar hot dog cooker or solar cooker is basically you take cardboard and you make it into a bowl, or you make like a little cone shape and you line it up with aluminum foil so it reflects all the light it gets from the sun in order to focus all that sun heat and energy on that actual hot dog to allow for you to cook the hot dog outside. This is kind of the same principle as if it's so hot outside, you could crack an egg and you could cook the egg on the sidewalk. Pretty much the same thing. Now, if you haven't made your garden bed, don't worry. The video in which I show you how we actually made this garden bed video from yesterday's webinar is on our YouTube channel. So I'm going to post that at the end of this. But if you go to Mbadika, M-B-A-D-I-K-A in YouTube, you'll find it in the day 8 video when we actually constructed this. So today we're just going to be doing the actual solar focus part. If you wanted to build this garden bed project and you haven't finished it already, don't worry. The video's online for you to actually do it, and we walk you through step by step. So first things first, I'm going to take my little cardboard prototype, and if I remember correctly, using my ruler, the actual length and width is 6 inches. I'm going to show you why this actually looks as rough as it does. I'm going to say it's largely because of the activities I've been involved or engaged in since yesterday, which I'm going to show you a sneak preview of. Someone just said move over to the side a bit. I got you. I got you. Guys, see my floor. I get it. I get it. Cameras change. Zoom's not always the friendliest. So we know this to be 6 inches by 6 inches. So if we were going to build something, in order to stand on top of this, we know it needs to be 6 inches. One of my initial design ideas was to actually create something that was pretty much like this shape, that will actually catch sun rays hitting from here and reflect it back down into this actual container. The reason why I was thinking that type of method in order to catch the sunlight rays is sometimes you're in a place that sunlight is not going to be shooting straight down. You're going to be catching it from an angle. So you can do it that way. This is the part that I say use your creativity. It's going to take a lot of iteration based on where you live to figure out different configurations. So what I'm going to do for my first actual prototype of this is I'm going to take some scrap cardboard. Now, my cardboard supply is running low because I've made 2 of these already, but I still have some cardboard from some drinks that one of my actual friends likes to drink all the time. So I took some cardboard from her. I'm going to transform this piece of cardboard into something I can use here. So let me go ahead and lower this. So with my piece of cardboard, I notice I already have some bins here that I could take advantage of. In fact, if I was being lazy, I could have my cardboard sitting up like this, have my little planter here, have aluminum foil here, reflecting down. But we're not going to be lazy. So what I'm actually going to do is build an attachment. But first, I need to measure out my cardboard to see how much I'm actually working with. So taking my trusty ruler, I'm going to go ahead and see how much is this little piece right here. So I'm noticing from here, and remember, we don't measure from the edge. Don't measure from the edge, we measure from right here, where we actually have our first marking on the ruler. You can see where I put the permanent marker, that first edge is 0. I'm going to take my second permanent marker, whichever one opens the fastest, and I'm going to do a line from there to here. And to right about here, I'm going to go ahead and write it down. It's about 4.75 inches. Now I'm going to see what's the actual width from here to here. And it looks like we're going to have to measure twice. Now this is very important. When we line up right here, I'm going to start from here. And we know this little piece is about, I'm going to go ahead, even though it's not, it's 5.6 inches. I'm going to be nice and say 5.5 inches. I can safely assume from here to here is 5.5 inches, but I like to be sure. So I'm going to go ahead, measure it out. And this here is also 5.5 inches. One of the things I'm thinking of actually doing is actually trying to create this side. If this was 6 inches, it would have been perfect, but alas, it's not 6 inches. Actually creating something that takes the sunlight and actually refocuses down here. So that's where this shape being applied here works perfectly. Again, this is not going to be the perfect one. It depends on where you live. I'm just showing you what I am doing based on my location. I notice when I'm outside, all the sunlight seems to be focused in this direction or this direction, depending on what side of the house I'm on. So I'm doing it with this angle, and I'm going to show you what I mean in a second. So here I have my piece of cardboard. What I'm going to do is cut this part out because this is the part I want to play around with. I'm using my X-Acto blade. So you see I have 2 blades out, and I'm using a ruler and pressing this down in order to actually cut it out. Now, the reason why I'm using an X-Acto blade is because I'm horrible when it comes to cutting things out. It's not my forte. So I like to minimize any issues that I may encounter when I'm actually doing this. If you're working with a pair of scissors, if you are skilled with scissors, stick with your scissors. It's totally fine. Don't worry about it. For me, I suck with scissors. I suck with markers. I suck with tracing. I suck with a lot of arts basic skills. So I'm using my X-Acto knife. If you're using an X-Acto knife, make sure you have a parent or guardian nearby. And just for those asking, why do I have this material underneath? This is a self-healing mat. So let's say I take my X-Acto and I cut through it. It doesn't damage my table. It just sticks onto the mat. So what I'm going to do, take this here, and I'm going to cut this. Now, one person's asking the way they made their solar cooker is they made a bowl. You can totally make a bowl, but it depends on how much sun exposure you have at your place. A bowl doesn't quite make sense for me, but if you guys want me to show you how to do a bowl, I can actually do a mini bowl video and have it tomorrow to show you how I would make a bowl version of this to be my little ultra focusing of light. Okay, I need to do a couple more passes. What I like about using this ruler, someone asked, are you using the ruler to protect your fingers? Yes. So you see where my fingers are. I'm using the ruler in order to hold the material down, as well as to protect my fingers in order to make sure my fingers don't become a casualty while using an X-Acto knife. You don't have this concern as much with scissors, but I'm going for that beautiful straight line. So as you can see right there, I went off the line. I retracted my blade, put it right here. Spin the cardboard a little bit. And now I can come through with my actual scissors. As you can tell, even though my place looks like it's nice and organized, I am still a very messy creator. I'm gonna come through here and start cutting. So it's starting to cut. And cutting down. Now I'm just using the natural creases here in order to make my version. Feel free to use what you have. You can even use something like this here and make it that you can do something like this. But I'm going to use this one because I like the unique shape. So this is really going to be based on whatever scrap cardboard you have, whatever neat designs you want to have with it. I don't like this piece here, so I'm going to cut it off. The purpose of this is just to have the light rays bounce off. So there's not going to be a one size fits all with this. This is just builds. If it doesn't work or you don't notice a difference, then go back to the drawing board. You can also use Tinkercad in order to brainstorm different designs you can possibly do. But here, we're just going at it. So instead of using Tinkercad as a blueprint, I'm going to show you how you'll make a quick first draft if you don't have time to use Tinkercad. And then, like with all things in life, you iterate or you make improvements based on what you see as the good things and the bad things, or the pros and cons of your actual design. So here, I have my design. I know this is 4.75 inches and this is 5.5 inches. What I want to actually note is 6 inches from this middle point here. So what I'm going to do, now that I've cut out the piece, hold it down. And since it's 4.75 inches from here to here, I'm going to whip out my calculator. I'm going to go, make sure you can see, ha ha ha. I'm going to go 6 minus 4.75 inches. That means it's 1.25 inches. 1.25 divided by 2 is 0.625 inches. So I need to go 0.625 inches from here and 0.625 inches from here in order to make my width 6 inches. Now, that's hyper specific. You don't have to be that specific. If you're not dealing with this kind of piece of paper or this kind of cardboard, you can actually make your width 6 inches from the jump. I just like to make stuff difficult because I like to test myself and push myself to the limit. As one person said with my my Arduino code, maybe I was pushing myself too much to the limit, but you know, who knows? Who knows? So right here, I'm just using my ruler to add 0.625 inches right there. I'm gonna make that line a little stronger down the center here. And what a neat trick that you can actually do with an X-Acto knife or scissors is, let's say we want to make a straight line up. You can actually make a crease, just like the crease right here, by very lightly cutting into it. So you see how I'm not trying to cut all the way through, I'm cutting very lightly. I'm going to do the same thing over here. We don't want to cut, we just want to make sure it's just very light passing. Or as one of my friends goes, we want a light stabbing, we don't want a real stabbing. And I'm going to use my ruler to bend. And you see that little crease I just developed? We got that crease. Like that. And then here, I'm going to use my ruler to bend and make a crease. So if you didn't have to deal with this little crease here, you can make a fake crease like I just did right here. So now that I have my fake crease, I'm going to look at how I want this to actually fit around my box. So bringing my box to the mainstream here, with my little fake crease, I can actually move us to the camera, fit it right here so it's corner to corner, or better yet, with my fake crease right here, one here, one here, I can actually have this sitting on each corner, and then have this laying out right here. So that way, it's perfectly aligned with this part, so it's going to catch all the sun rays coming straight down. I like this setup, but I need to add something to reflect all those sun rays. And that part is going to be our aluminum foil. So what I'm going to do is going to take my aluminum foil. This is not a webinar sponsored by Reynolds. That's just what we happen to have in the house. I'm going to cover that actual piece. Now, some of you are asking, okay, but when you cover it, what is going to be the actual piece that you use, or the glue that you're going to use to cover it? So I'm going to use my trusty glue stick and my glue gun. Let me clean this up a little bit so it looks pretty for the camera. So you actually think this is how I operate, this is how I am in real life. And I'm going to try to position my aluminum foil, probably easier this way, to do the most coverage. So here, I do my longest edges there. I'm going to move it, say a little bit bye. When there's too much stuff on your workstation, because you're doing too much. So as you can see, I'm doing from corner to corner. And once I get those corners down, I like to actually go in with my aluminum foil and do a trace, right? So what I'm going to do with my permanent marker, just so I know what's the actual part I'm going to cut out, I like to trace because it makes it so much easier for me. So taking my permanent marker and tracing. Tracing as much as I can. Boom. Once I have that, I can go behind with my scissors. I'm going to use my X-Acto still because she's liking me today, so I'm going to stick with it. Now, as you notice, you got to move quick because the aluminum foil will follow you when you're cutting, and you want to make sure your cuts are pretty precise here. So you see how a little bit of it's dragging? I'm going to go behind and just gently lift. Now, aluminum foil is very thin. She's very temperamental. So when you got to cut precisely, or she will drag behind you. So you see here, boom. Putting my aluminum foil to recycle for later. Always recycle. I'm going to move this up so you can see the whole thing because this piece is so big. And now that I have the major part, I'm actually going to switch to scissors as someone recommended because they wanted to see scissors. So very carefully cutting the outline here. And taking my scraps and putting it in my recycle section. And then once I finish with the aluminum foil, I'm going to glue it to my cardboard. Now, if you want to hold your cardboard template while you're cutting, feel free to do so. Just going to straighten that out. Ugh, I snagged this bit, but that's okay. I'm going to cut my last side. And then here. Booyaka. And so we have our trace outline. I'm going to go ahead. Make sure she's all good. I messed up a little bit of the corners, but that's okay. I can use my scrap aluminum foil to fill up these corners here. And then I'm going to see if my glue gun's ready. Okay, she's ready. So I'm going to do a quick pass. Oop, and of course, my glue gun needs a stick. She needs a stick. Now, if you're using a glue gun with aluminum foil, heat transfers through metal. So make sure that you're very quick when you're working with it. You don't have this problem when you're using a glue stick. If I had a glue stick, I would totally use a glue stick for this part. But I don't have one because somebody in this apartment / house decided to use it for some kind of project. I won't call out any names here. So I don't have my glue stick. So here, I'm going to actually just use my ruler to stretch it out as much as possible. And I'm going to put, because I'm a little particular about making sure there's maximum coverage, I'm going to take a couple scrap pieces, cover up the bottom, and fold it over the actual prototype. See, scraps always come in handy, so always recycle building materials because you never know when you're gonna need them. You can add a little glue there just to make it a little bit easier. This part I totally trashed, so this is gonna take a little bit more aluminum foil. Once we finish this part, we can actually go ahead and glue it to our garden. So here, remember, I'm bending it right here at my new crease that I'm making. Oh no, I did it backwards. Oh well, I'll just show you how I would do it. Is add a little bit of hot glue or glue this part. Put it on the very upper lip of my actual garden bed. Have it lie down. hold it. Oh, a little piece of aluminum foil is floating up there. Lift it up. And that way, when the sun hits it here, it will bounce actually here into our actual planner in order to bring some much well and welcomed UV light into our little garden bed. So I did this one based on how it hits my house, which sunlight hits here. So the sunlight actually has a chance of actually touching my stuff in here. So this is how I did a very low-tech solution versus actually doing my little UV lights. Now, if I wanted to be extra, I can actually plug in my power source or program it with my Arduino board. And you can see here that I can actually make sure that when I do it this way, that some are actually hitting my little lights here. So I will continue iterating on this one, but this is an example of a way that you can do it with UV LEDs if you have them, or with aluminum foil. Always make sure, don't be afraid to iterate or practice when you're actually doing this and making improvements. Now, someone was saying, should you continue saving coffee grounds? As I mentioned before, you can always add a little pinch more to your actual seedlings. Oh, you guys can't see. Okay, hold on. You can always add a little pinch, add a little bit of moisture to continue your actual garden. But before we sign off for today, and you continue working on this, some of you guys asked me for some quick tips on decorating your actual garden. So if you want to stick with your cardboard version, what I would actually use is some quick drying acrylic paints. So when you're using acrylic paints, for example, they actually work really well with cardboard. So you have any of these in your house, I would recommend using these. As you can see here, I have a couple of colors available here in order to do so. Another trick that I have if you want to decorate is feel free to use gems and a hot glue gun or Elmer's glue to decorate the outside so it doesn't look like an Amazon package. A quick tip if you're looking for cheap prototyping materials is if you go to home improvement stores, you'll find an oopsie shelf in the paint section. And the oopsie shelf, you'll find all these color samples. And instead of them costing $3, you can find random paints for like $1.25. So this is what I actually always look in the oopsie color section of the paint section of the home improvement store to find cool paint colors that I can do. Now, some of you asked if you could do spray paint. You can spray paint, but just be careful because of the fumes. Now, don't forget that this project, along with other projects, actually qualifies for the Instructables and Tinkercad distance learning program or contest, actually. So this project, along with other projects we've done in other webinars, actually qualifies. So don't forget that improving upon your actual design works, and that there could even be some moolah or some prizes for you if you actually submit and get selected. So don't forget to actually submit to that. You can find more information about the distance learning contest via the Tinkercad blog. So if you go to tinkercad.com and look for blog, you can actually see all the contest rules and suggestions, as well as the deadline being June 1st for you to submit your project. Now, one person was like, you keep asking about wood, but how did you do your wood one? This here, this bad boy, is my wood prototype. Hope you can see. So I actually made this yesterday, and I used wood glue and all the shims. So if you look here, you can see I actually double layered all the shims, and I actually used this oopsie paint in order to paint my actual garden bed. So I'll post a picture once I get all my plants and stuff in it, but this is what it actually looks like as a full size. And let me see if I can take this off to give you guys a better view. Oof. So this is what it actually looks like. If we look at our smaller prototypes, you can actually see that it fits about a little bit more than what we originally estimated, and that's because I had to double the thickness in order to support all the plants that I wanted. But this is the same building material that we used previously. Oops, sorry, I put my finger in the way. So these are made from the same number of shims. So as you can see here, this was the building material I used, and there's 1, 2, 3, 4, 5, 6, 7, 8, just like our Tinkercad model. If I change it to a side view, you can see, whoop, if I change it to a side view, I'm doing too much. There's 1, 2, 3. So our actual Tinkercad model did work out in real life. So this is just an example that Tinkercad can be used for a blueprint for your real life projects. For those who are asking, we did all that work And we never saw your wood version. Yes, the wood version did exist. Yes, it did happen. It is right here. And compared to the cardboard version, it's not that off. There's a little bit of a gap because some of the wood buckled, etc., but it's pretty dead on. So
My word, have I been talking this entire time and no one can hear me? I apologize. Welcome to DJ Sometimes Isn't Doing Too Well. So here's the actual URL for the distance learning contest that is being hosted by Instructables and Tinkercad. I hope you guys were able to see the garden project and see a little bit about that. But until next time, I hope you guys continue to tinker together. Thank you so much for spending this now afternoon based on my time zone with me. And I hope you actually enjoyed this project. Tomorrow, we're going to move into our last project, which is going to be pretty much a catch-all be-all project that I've been cooking up over the past couple of days to celebrate almost 2 weeks of our Tinker Together sessions. So until next time, guys, don't forget to build, make, learn. Ciao.